Today we're working on section 3, which is square root functions and inequalities. So we've done square roots before. I suggest and hope that you know at least through the first 12 or 15 square roots. It wouldn't be a bad idea to know the first 20 of them. However, this is not a requirement. I'm not going to quiz you or anything on it. I did that in Algebra 1 and pre-algebra. So, we are just going to focus on the graphs of these and actually solving for things given square roots. So not a long lesson. I did take out some of the examples from what's on your notes. There are some additional ones there, some additional graphs. I would suggest you try those on your own, so that way you can kind of see what's going on there. But I thought with us having so much in-class time, with you working on homeworks and things, I didn't feel the need for me to go through those again. So a square root function is just a function containing a square root of a variable. So it doesn't include, if I were to say the square root of 2 times x, that is not a square root function. It's not the coefficient, it's the variable. So you'd have to say like 2 square root of x. That's a square root function. So notice I have two different things here. I mean, there are three colors, but really two different things. The one is a quadratic. We've dealt with those, we've solved those, so we know what that graph looks like. The other one going here, the red color, is the square root of x. Then the color below that, that purplish blue color, is going to be the negative square root of x. And so looking at those, that's the inverse of the square of this quadratic function. So you'll kind of notice that it's really just the quadratic leaning on its side. So those are what our graph should look like. So when I take a look and I graph this, it says graph y equals the square root of 3x plus 4. So you have the domain, the range, and the x and y intercepts. The easiest way is just going to be doing a table of values with this. So if I look at doing a table of values, if I plug in when x is 0, let's say. So if x is 0, 3 times 0 is 0, plus 4 is 4, square root of 4 is 2. So then when x is 0, y is 2. I want to start when they're both 0. That's where my graph really starts. So I can continue and find a few more values, but I am going to have to go negative. So how do we find out where to start? The easiest way would be to say 3x plus 4 is equal to 0. Find out where that equals 0. Subtract 4, so we get 3x is equal to negative 4. X equals negative 4/3. So that's really where we want to start our graph. So I'm going to move this down just a little bit. I'm going to plug in a negative 4/3 here. And I already know when I plug in negative 4/3, the inside is going to be 0. So now I know back here at negative 1 1/3, that's my 0 point. So then let's continue and plug in some more values. So let's plug in then, we'll go 2, when x is 2. When x is 2, 2 times 3 is 6, plus 4 is 10. So this is the square root of 10, which I believe should be 3 point something. I think it's like 3.1 or 3.2. So let's take a look at that square root of 10. Yeah, 3.1, we have 1/6. We can round it off to 3.2. And so when I graph that, we get when x is 2, y is 3.2. And so this is my square root function. I do not graph the other half. The bottom half is the negative square root of x. I'm not worried about that. I'm just worried about the positive square root of 3x plus 4. And so that's all let's do it. Now, they ask us for the domain, the range, the x and y intercepts. So my domain is really all of my x values. What's my domain? X greater than or equal to negative 4/3. It's this value here in the domain. Well, what's my range? My range should always be, for the most part, y is greater than or equal to 0. Remember, we can't go negative here. X can go negative because it creates this to be 0. Y can't go negative, so this has to be greater than or equal to 0. So my x-intercept was at negative 4/3, so that's also my x-intercept. And my y-intercept was at 2, so this is my y-intercept. And you can see on the graph, y-intercept when x is 2, x-intercept when y is 0. So let's go ahead and look at another one of these. Alright, so the square root of 3x over 2. When does x make that 0? When x is 0. Because if I plug in 0 for x, this whole thing becomes 0. So I'm going to start at 0, and that also makes y 0. So my starting point this time is 0. Now if I plug in, that's not really going to matter because they're all going to be decimals. So if I were to plug in a 1, I get the square root of 3/2, which is approximately going to be 1.2. So when x is 1, this is at 1.2, and we'll just do one more. When x is 2, it's going to be the square root of 3, which is approximately, I believe that should be 1.7. Yeah, 1.7. I just like to double check myself. And we're up here, and so this is now my graph. So the domain and the range. Domain. Oh yeah, I'll write it that way. So again, remember the set builder notation? We haven't done this for a long time. So all the values of x such that x is greater than or equal to 0. And then the range, all the values of y such that y is also greater than or equal to 0. So that's what we call set builder notation. We touched on it way back in the beginning of the year, but we haven't done it for a long time. So now the second part of this question asks us, solve for x if y is equal to 3. So if I make y 3, we're going to have 3 is equal to the square root of 3x over 2. Well, how do I get inside of there to solve for x? I have to square both sides. So to undo a square root is by squaring it. So 3 squared is 9. Now nothing inside the radical gets squared. It just cancels the square root. So it stays 3x over 2. And multiply by 2. So we get 18 is equal to 3x. Divide by 3. X is equal to 6. So again, to undo a radical or a square root, you have to square it. And when you square it, nothing on the inside gets squared, just cancels the square root. So we have one more definition, one more example here. A square root inequality is just an inequality that involves square roots. So I know it's a super high-tech definition. So we're going to go ahead and just solve with this square root inequality. We're going to graph it. So when I graph it, we're going to graph it just like normal. I'm going to plug in some values for x. So we're going to start with setting the inside equal to 0 to know where to start. So I have 2x is equal to 6, x equals 3. So if I start with 3 this time, so I'm not even going to go the whole way back down to 0, I'm going to start with 3. When I plug that in, I get 0 for y. Well then when I plug in, so then I have to go from there. So when I plug in a 4, I get 2 times 4 is 8 minus 6 is the square root of 2, which is approximately, I believe, 1.4. Then when I plug in a 3, we get 3 times 2 is 12, or excuse me, 6. Oh, I'm sorry, I'm going the wrong way. 5. 5 times 2 is 10, minus 6 is 4, which is 2. So then we have 3, 0, 4, 1.4, and then 5, 2. Now, I have inequalities again. Remember, that means a dotted or solid line. So because it's not or equal to, this is going to be a dotted line. Just my inequality, but it's dotted. And then I have to determine, am I going to shade underneath the radical, or am I going to shade around the radical? So I'm going to, again, we can plug in that 0, 0. So if I have 0 is less than the square root of 2 times 0 minus 6. That's not going to work, because I'm going to end up with 0 is less than the square root of negative 6, and that's undefined. I cannot have that happen. So when that happens, we have to pick a value that actually works in our domain. So with this one, I could plug this in if it's in my domain. For this one, it's not in my domain, so we can't choose that this time. So let's choose something in the domain. So let's say we'll choose the point 4, 4. So I'm going to go over here to 4, 4. I'm going to test that point there, and we're going to see if it works or not. So if I have 4 is less than the square root of 2 times 4 minus 6. So 4, I want to be less than the square root of 8 minus 6. Is 4 less than the square root of 2? No, it is not. So that is false. So that doesn't work. So I'm shading everything on the inside here. Now, I don't just shade above the x-axis. I kind of draw this invisible line here, and it's everything underneath that radical, all the way down. All of those things work. Alright, and that completes our lesson. So like I said, not a super long one. Go ahead and please try some of those additional examples on the paper. Because I would like you guys to kind of get a feel for that and see if you can get those answers without me working through them with you to see how you do.